Well, welcome. In this video, we're going to be looking at how to find the mean and standard deviation of a binomial random variable. Now, you might be saying, haven't we done this already? Didn't we already do this in a previous lesson? And we have. But in the previous video, in the previous lesson, for lesson 10.4, if you recall, the process was kind of a complicated process where we had to create a distribution table and multiply the value for the random variable times its probability, add those all together, and that would give us the weighted average or the mean for that binomial distribution. There is an easier way to do it. I'm sorry that we had to wait this long to show you this, but now you're going to be able to see a simpler process that we can do to find the mean, the standard deviation for a binomial distribution, for a binomial random variable. Now, it's important to recognize that these only work for binomial random variables. And these are situations where you have a P and a Q, a situation where we have a probability of a success and a probability for a failure. Other situations this would not work for, but it does work for situations involving binomial distributions and binomial random variables. So let's look at this simple technique that we can be using and apply it to some situations. And let's just look to see how much easier this is than the method that we learned previously. Well, here we can see from this box that to find the mean of a binomial random variable with n trials and a probability of success being p on each trial is given by the simple formula of n times p. For example, let's look at this one here, where it says, each day for 4 days a radio station is holding a raffle to give away a pair of tickets to an upcoming concert. In the past, the station has found that 80% of the raffle entries are from the local area. If this is the case, find the mean of the random variable x, where x is the number of winners from the local areas. So in the previous lesson, from lesson 10.4, we would have had to come up with this table, where x represents the number of local winners. So we could have 0, 1, 2, 3, or 4 local winners. And then to find the p of x, we would take, for example, for the first one, we'd have to do 4 choose 0 times 0.8 to the 0 power times 0.2 to the 4th power. That gives you 0.0016. And then to find the next one, we would take 4 choose 1 times 0.8 to the 1st power times 0.2 cubed, and so on. And we would get those numbers in the table. Then we'd have to go through this process of taking 0 times the probability, plus 1 times its probability, plus 2 times its probability, and so on. And when you add that, when you get that sum, you end up getting a total of 3.2. Well, we could do this a much easier way from what we're learning about today in this lesson. And we would just take your number of trials, which is 4, and the probability for each of success in this case is going to be 0.8. Multiply those together, 4 times 0.8, and you get your mean of 3.2. Wow, a lot easier doing it this method. Again, I am so sorry that we did not reveal this to you earlier, but at least now you can appreciate the fact of just how easy and how much more convenient this is than the previous technique. So why don't you guys try this one on your own? Chris is a basketball player who makes about 30% of the three-point shots he takes. If he takes 8 shots in a game, find the mean of the random variable x, the number of shots he makes. So why don't you pause this video, and why don't you use the technique, use the theorem that we just learned in this lesson to find the mean number of shots he would take here, or he would make, I should say. Okay, let's see how you did. So what you would do is you would take, in this case, the number of trials, or value for n would be 8, because he's taking 8 shots. The probability of a success is 30%, or as a decimal would be 0.3. So we'd multiply those two together. 8 times 0.3 gives us 2.4. So we'd expect that he would make about 2.4 shots per game. Now remember finding the standard deviation, or the variance. We actually had to find the variance first, previously in lesson 10.4. And once we found the variance, to find the standard deviation, remember we just take the square root of our answer. Well, there are two techniques. Personally, I prefer this second technique, where we take and square the value for each of our random variables, and then multiply that times its probability, add those all together, so find the sum, and subtract from that sum the square of our mean. Again, it was a long process. Guess what? We have an easier process now. To find the variance, we're just going to take the number of trials times the probability of a success times the probability of a failure, and that gives you your variance. Yes, it is that easy. To find the standard deviation, we just take the square root of that. So let's look. We're going to skip that example 2a that I scribbled out here. But let's look at this one. In the situation of example 1b, where Chris is a basketball player, makes about 30% of the shots, 3-point shots he takes. If he takes 8 shots in a game and blah, 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 blah. We want to find the variance and standard deviation of the random variable x. So for this situation, again, our number of trials is 8 shots. The probability of a success would be 30% or 0.3. So that means the probability of a failure would be 1 minus that, which would be 0.7. So we would take, to find the variance, we would take 8 times 0.3 times 0.7 and get our answer of 1.68. To get the standard deviation, we would just take the square root of that. The square root of 1.68 is 1.3. And it really is that simple. Let's look at another one together. In the United States, about 49% of newborn children are female. Suppose a large hospital has 2,500 live births in a given year. Let P of x be the probability that x female babies are born in the hospital. What is the mean of the random variable x? So in this situation, the number of trials is 2,500. The probability of a success is going to be the probability of having a female baby, which is 49% or 0.49. So to find the mean, we would multiply the n times p, which would end up being 2,500 times 0.49. Get your answer then of 1,225. So we'd expect out of those 2,500 births to have 1,225 females. What is the standard deviation? Well, remember the standard deviation is the square root of n times p times q. So in this case, if p is 0.49, q would be 0.51. So we would take the square root of 2,500 times 0.49 times 0.51. And when you do that on your calculator, you get 25. Why don't we end by looking at this last example? So I want you guys to try this one completely on your own. So why don't you pause the video and hit play when you're ready to check to see if you have the correct answer. Okay, let's see how you did. In this case, about 14% of the population of San Diego is of Asian origin. Suppose that there is a job opening in the city that requires a person to live in San Diego. If 200 people apply for the job, let P of x be the probability that x of the applicants are of Asian origin. So in this case, again, to find the mean, we're going to take the number of trials times the probability of a success. In this case, the probability of a success is going to be 14% or 0.14. And we have 200 applicants. So we would take 200 times 0.14. And when we do that, we get 28. So the probability, or our answer here would be that the mean number of applicants that are going to be Asian would be 28. To find the standard deviation, remember to do that, we take the square root of n times p times q. In this case, again, n is going to be 200. P, our probability of a success, would be 0.14. The probability of a failure then would be 1 minus 0.14, which gives you 0.86. So we would take 200 times 0.14 times 0.86. Do that on your calculator. You should have gotten 4.91 approximately as your answer. And that really is how easy this can be when we're dealing with binomial random variables. So with that, good luck now as you work on your assignment.